So I follow a simple 3-step approach, which is cool. So in the first step, you have to look at the pH, bicarbonate and PaCO2, and you have to find out the primary disorder. You have to find out what is the primary disorder. That's the most important. So if you look at this table, what you're going to first do is you're going to compare the pH with the other two numbers. So if you compare the pH with the other two numbers, you can notice that in some situations, the pH and the other two are going in the same direction. In certain situations, pH and the other two arrows are going in the opposite direction. So this is where we're going to use the Rome rule. So respiratory opposite, metabolic equal. Okay, respiratory opposite, metabolic is equal. So to find out whether it's a respiratory or a metabolic problem, I'm going to use the Rome rule. Just see the pH and the other two arrows. If the pH and the other two arrows are going in same direction, like what is happening here, it must be a metabolic disorder. So it's equal. Similarly, pH and the other two arrows are moving in the same direction. So this also must be a metabolic disorder. If the pH and the other two arrows are moving in the opposite direction, this must be what? A respiratory problem, because respiratory is opposite. Similarly, if pH and the other two arrows are moving in the opposite direction, it must be again what? A respiratory problem. As simple as that, right? So now just look at the pH and decide what is the issue. So if pH is low, it must be metabolic acidosis. If pH is high, it must be metabolic alkalosis. If pH is low, again, it must be metabolic acidosis. If pH is high, again, it must be respiratory alkalosis. Got it? So now easily you can find out what is the primary disorder. So now the question is, what is the average pH? Average pH is 7.4. Anything less than 7.4, you can take it as acidosis. Anything more than 7.4, you can take it as alkalosis. By default, this is only to solve the problem. In reality, it doesn't work. The normal pH is 7.35 to 7.45. So the whole range is normal. But for calculation purpose and for mathematical purposes, we can keep it as what? 7.4 as an average. And for just solving the problem, you can say less than 7.4 is acidosis and more than 7.4 is alkalosis. So only for solving problems, that's it. And the average bicarbonate is around 24. So more than 20, the exact value is 22 to 28. But less than 24, you can take it as low. More than 24, you can take it as high for problem solving purposes. Similarly, PaCO2 average is 40, but it ranges from 35 to 45. You know that. So again, for solving purposes, less than 40, you can take it as low, and more than 40, you can take it as high. So now it's a very simple rule, right? So in exam, in just 2 seconds, you can find out which is the primary disorder. Are you understanding the point? So whether it's a metabolic acidosis or alkalosis or respiratory acidosis or respiratory alkalosis. Very, very simple. That's all. Just 2 seconds is all it's going to take. You find out whether it's a metabolic or a respiratory disorder by default. And another thing, now I wanted you guys to concentrate on the center box. This is what I've written, right? The center box. In the center box, what you are seeing, either the arrows are moving in the same direction, right? All the arrows are moving in the same direction. So it works without exception. All the arrows are moving in the same direction, okay? So now you can see that all the arrows are moving in the same direction. Listen carefully. So in case if the arrows are moving in the opposite direction, for example, bicarbonate is decreasing, PaCO2 is increasing, or bicarbonate is increasing and PaCO2 is decreasing. Yeah, I always used to tell you have to thank the examiner, because this is 100% a mixed disorder, because examiner is trying to save your time. Okay, this is 100% a mixed disorder. This cannot be a single disorder. If bicarbonate and PaCO2 are moving in opposite direction, unlike what is happening in the box that I have written above, this is 100% a mixed disorder.